Hello ladies and gentlemen, today we have our next lesson dealing with functions. And what is a function? As you go through the lesson, again, if you would like to pause to write anything down, you may. If you want to rewind to watch something again, please do so. But today we're going to talk about what is a function. Well, I got a couple examples I want to talk about to begin with. The first thing is we have a vending machine here. This vending machine has different types of drinks in here. The buttons on that vending machine, A1, A2, B1, B2, C1, and C2 over here. Now I want you to think about it. When you are at a vending machine, if you press A1, you're pressing it because you want orange juice. You press B2, it's because you want chocolate milk. You press C1, it's because you want water. Right? That makes sense. And a vending machine is like a function. You press a button, you expect something out. Well, look over here at this vending machine. It's fine for orange juice. If you press A1, you're going to get orange juice. But look at the next one. If you press A2, it says here that you might get apple juice or you might get skim milk. Well, if you wanted apple juice and skim milk falls out, you're going to be a little mad. This is the idea of something that is not a function. With a function, if you input something, you say, I want this, you better get something else out. If I say, I press A2, I better get apple juice. That is the idea of a function. This shows that, well, if I press A2, I could get either or. That's not how we want things to work. All right? Let's take a look at the next one. If you look at that same situation as a graph, over here, everything lines up. A2 gives you apple juice. B2 gives you chocolate milk. C1 gives you water. Just like it's supposed to. But we have an issue over here when we get to A2 on the second machine. On A2, it tells you can get skim milk or apple juice again. That doesn't work. And look to see how the graph looks. That's very important. Next, if we look at a table. This table over here, pretty self-explanatory. If you have A1, you better get orange juice. B1, you better get skim milk. B2, you better get chocolate milk. Over here, if you notice, A1's fine, but then we have two A2s. That doesn't work. You don't have two different buttons. You only have one in a real function. So this one over here shows you we don't have a real function. Alright, so for your notes, what is a function? This right here is the formal definition of a function. For a relationship to be a function, any given x can be paired with only one y. That is the formal definition. I'm going to give you another one to think about. This one here. For each input, there is exactly one and only one output. For each input, there is exactly one and only one output. Alright. Make sure if you need to pause that, do so. So, what we're going to talk about here is these inputs. Right? I have some words here. We talked about these when we did independent, dependent variables. Independent variable, your domain, your input, x, those all mean the same thing. That is what you're starting with, what you need to know first. Right? What we have here in the middle is we have a function. Right? And out here, we have the dependent variable, the range, the output, your y coordinate. So, how a function works is like this. You start off with what you need to know first. Your domain, your input, your x value, your independent variable. Let's say that we give a value to your input of 5. If you take that 5 and you input that into this function, in this case, our function is 3x minus 1. We would write 3 times the input, which is now 5, minus 1. When you do that, you're going to get exactly one output. And that output, 3 times 5 is 15, minus 1, which is 14. Each time you plug, or you input a 5 into this function, 3x minus 1, you will get exactly one answer, 14. You will never plug a 5 in to 3x minus 1 and get us 46 or 32 or a negative 9. For each input, you get exactly one and only one output. That's the nice thing about a function. It's very predictable. Think about this. If I give you a negative 7, we're saying the input into this function is a negative 7, your domain. You plug that in. 3 times negative 7 minus 1. Order of operation. 3 times negative 7 is negative 21 minus 1. Same signs, add them together, keep that sign. End up with negative 22. For each input, you get exactly one output. Guaranteed. Alright. So, what we're going to talk about today is what is and what is not a function in different representations. The first representation is going to be ordered pairs. So, what we have here, we have a set of ordered pairs. Now, the nice thing about ordered pairs is it's really simple to figure out which one is and is not a function. For each input, you can get exactly one output. So you can only have one value of x for each value of y. So, here's your rule. If x ever repeats in that set of ordered pairs, it is not a function. If x ever repeats, it is not a function. So, if we look, a, 3, negative 2, 4, those are your values of x. So, x doesn't repeat. So this is a function. Alright, and again, it's because x doesn't repeat. The next one, 3, 2, 9, 3. I want you to notice. The x value of 3 repeats. If the x value of 3 repeats, it is not a function. Right. Take a look at C. 5, 2, and 1/2. X does not repeat. So that means for every value of x, you get exactly one value of y. So that is a function. And then lastly, D. 4, 7, negative 4, and 4. X repeats. So this is not a function. Alright? Alright, so let's move on. And again, if you need to pause, do so. What we call this is we call this mapping. This is another way to represent a set of ordered pairs. The first bubble is your x-coordinate. The second bubble is your y-coordinate. Right? You can write these as a set of ordered pairs. But what you're doing is you're looking to see where the x value points to the y value, so wherever the arrow goes. So as you look at this, you can write this as negative 2, and it points at 1. You can write this as 3 and 0, 4 and negative 0.5. Okay? Now if you notice over here, x doesn't repeat. So this is a function. But if you're just looking at the mapping itself, what you're looking for is you're looking to see if any value of x has more than one arrow coming from it. As long as it has only one arrow coming from it, it is a function. Just like example when we look at B, the value of 3 has two values. And what that's saying is the value input of 3, I could get 4 or 7. That's not true. Right? You can only get one value. So this is not a function. Down here at C. Now if you notice here, these two values go to 4. That's fine. This is the y-coordinate. We don't care about that one. As long as x doesn't repeat, we're good. So as we look at this, you have one arrow coming from each value of of x, so this is a function. Alright. So let's move on. Next one, tables. Tables are pretty simple. Tables are just like a set of ordered pairs. As long as x doesn't repeat, this is a function. So the first one, x doesn't repeat, is a function. Look at B. X does repeat. 3 can't be 4 or 7. Okay? So, this is not a function. And down here, as long as x doesn't repeat, it is a function. Alright? Alright. So, next thing. Graphing is another way to represent a set of ordered pairs. Now, when we have this, there's a place for you to write this. We have a certain rule that we use for graphs, and it has a name, a special name. Right? And it's this one down here. We have a test that we run, and write this one down. Pause if you need to. Vertical line test. With any vertical line drawn through a function, that vertical line can only touch the function one time. So, I'll show you how the vertical line test works. What you will do is you will take that set of ordered pairs or that line. You will draw vertical lines throughout that graph, and you notice some on here already. As long as your vertical lines only touch those points of that line once for each vertical line, then it is a function. This one only touches once for each one. So this is a function. If we look over here at B, you can draw vertical lines through this one. But you'll notice down here on the right, it touches 2 points. That vertical line touches 2 points. That means it has a value of x that has 2 values of y. We can't have that. For each value of x, you can have only 1 value of y. So that is not a function. So you can see. Now we have a line. Same idea though. As long as these vertical lines only touch once, then this is a function. Right? And this is definitely a function. We'll talk about these quite a bit this year. Alright, so let's move on. D. D is a very important one. If you'll notice, D is a vertical line. So, if you draw a vertical line through a vertical line, how many times do you touch it? Well, every single time, an infinite amount of times. So, vertical lines, this is very important. You might even want to write this down somewhere. Vertical lines are never functions. A vertical line is never a function. That's very important. Alright, E. E is one that messes some people up once in a while. But as you'll notice, each time I draw a vertical line through here, I only touch that line once. This is most definitely a function. And then the last one, you guys can probably guess this one. F. Alright. You'll notice that when you do this, you'll hit it multiple times. So this one is not a function. Alright. So, next one. Equations. To tell if an equation is a function, we have a rule. It's down here at the bottom. An equation is a function as long as the independent variable is in the numerator of the equation and the exponent is positive. Independent variable, we've talked about that. You've looked at that quite a bit. Independent variable, all right, is the one that deals with the function itself. The variable that is by itself is your dependent variable. That's your answer, what you're trying to find. So as we look at this, we have this f of x. Well, this f of x stands for y. We'll talk about that later. But this x plus 1, that's your function. So the x is your independent variable. As long as that's in the numerator of any fraction, it is a function. The independent variable for b is w. Alright, that's in this function right here. Now, the key is to understand that this says negative 2/3 times w. Well, that w is in the numerator. So this one is also a function. Alright? For c, here's your function, 2m minus 5. So your independent variable is the m. And if you'll notice, that m is in the numerator. This one's also a function. Alright? D, this is your function, g squared. As long as the exponent is positive, this is a function. Because you'll notice in E, your function is x to the negative 3rd power. That's a negative exponent. This is not a function. And then lastly, I want you to look at F. This can also be written like this. 1 over x cubed. And as it says, as long as it's in the numerator, this one's in the denominator. So this one is not a function. Alright. So, got a couple I just want to go through. Alright. I want you to pause this for a second. Stop it, and I want you to try to answer these. Then I'm going to give you the answers here in a second. So you pause it right now. Answer these, whether it is or is not a function. Tell me whether it's an equation, an ordered pair, graphing, or mapping. And then you can go over the answers. Alright, so here are your answers. First one, ordered pair. And this one's an ordered pair too. Okay? The first one, as long as x doesn't repeat, it is a function. On the second one, x repeats with the -3. This is not a function. On 3, known as mapping. And 4 is also mapping also. Okay? If you'll notice here, you have 3 different arrows coming from that 1. That is your x-coordinate. This cannot be mapped. This cannot be a function. On 4, as long as 1 arrow is coming from each value of x, then it is a function. Lastly, number 5, 6, and 7. Well, hopefully you can tell me that these are graphs. Each one. Now, vertical line test. That's the test we run for graphs. As you go down, hopefully you'll notice, in that first one, you hit these 2 points with one of those vertical lines. It is not a function. On 6, vertical lines throughout. You only touch it 1 time. So that is a function. Then lastly, number 7, vertical lines. Again, hopefully you notice right away. You touch that more than once. These are not functions. So, come in with questions. I'll help you out. If you do have any of them, we'll go through. All right. So, you guys have a great evening.